Okay, 15 is a great problem right here. What we have on 15 is that we have two triangles sharing one side. The top triangle here is a 30, 60, 90 triangle, and the bottom is a 45, 45, 90 triangle. We're gonna keep this exactly the same, solve it exactly how we've been working. The only thing is we're gonna ignore this bottom part right here. We're gonna work this in two phases. We're gonna look at this 30, 60, 90 first. There's my 60, there's my 30. And given that this side here is 9 square root of 3, I want to label this out. Opposite of the 30 is x, opposite of the 90, 2x, opposite of the 60 is x square root of 3. I'll let you get a little time, draw that out, have that on your paper. Very important right there. Hopefully you're catching on to this and jumping to and knowing what x is right now. But even if you don't, x square root of 3 equals 9 square root of 3. And looking there, x has to be 9. So that tells us that this side here is 9, and this side here, 2x, 2 times 9 is 18. So SW is 9, SA 18. That's halfway. Well, we have to look at the other half, this 45, 45, 90 triangle, to figure out what it is that we need to use. So opposite of the 45 is x, opposite of the 45 is x, opposite of the 90 is x square root of 2. All right. Now, using what we know from the last thing, that this SA is 18, okay, I'm going to look at this and I'm going to solve this as x square root of 2 equals 18. We're solving for x, but I want you to remember that this is different than what we did here. This is part 2 to this problem. I'm going to divide by the square root of 2. The reason why I did that is because this is x times the square root of 2. So I got to counter with division. But if I do it to the left, I have to do it to the right. We talked about a rule last time is that if you have a square root on the bottom, you got to get rid of it. Can't have it. So you take that number, square root of 2, and you multiply the top by it, multiply the bottom by it. Across the top, 18 square root of 2. And along the bottom here, you end up with 2 because you get the square root of 4, and the square root of 4 is 2. Okay, we just want to look real quick. Does this simplify? Does 18 divided by 2? Yes. We get 9 square root of 2. 9 square root of 2. So, S to T, that's x. This x, the 45, 45, 90 part of this, is 9 square root of 2. A to T, or TA, would be exactly the same. I know a lot of times people get confused about, well, hey, you said x up here was 9, now you did it down here, and it's 9 square root of 2. Just remember that the first phase of this was up here, and we solved for just that top half. Got the information we needed, and then went to the bottom half and solved it separately. All right, on the trig part of this, we are actually going to take a day whenever I get back and I'm with y'all to really go over this trig, and we'll spend a day on it, and we'll take some time and do some work on that. But for now, don't worry about this, 16 through 23. We're going to move on past that. We're down to the review problems, and what we're going to talk about here is B is between A and C. We talked about this a long time ago. You have a line segment, endpoints A and C, and B is between. It doesn't mean it's in the middle. We're not saying it's just somewhere in between these two. We have B. Now, A to B is 2x minus 5. B to C is x minus 2. The total distance from A to C is 20. I want to set up an equation using this diagram right here, A, B, and C, to solve for x. What we need to be thinking about here is that, hey, this segment plus this segment, if I add them together, that has to be 20. So then this equation and this equation, if I add them together, it has to equal 20. How many x's do we have if we add these together? And negative 5 and negative 2, if we add those together, is negative 7. And that has to equal 20. Now I want to solve this out. I'm going to add 7 to both sides. 3x equals 27. Divide by 3. X equals 9. They want to know what AB is, not X. We're not done. AB right here, I have to take my 2 times 9 minus 5. 2 times 9 is 18. 2 times 9 minus 5. 13 is my answer. Similar type of problem that we have here, except this time we're dealing with the angle. We have an angle that's ABC. And BD bisects it. This is ray BD. So this is a ray that's coming right down the middle. And remember that bisect is a word that means cuts it exactly in half. ABC is 67. That's this whole angle is 67 from A, B, and C. This whole angle, 67. ABD is this portion right here. What I got to remember is that this is a half, not the whole piece. Okay? But for us, if this half is 3x minus 1, then the other half has to be 3x minus 1 also. Remember that word bisects? Cuts it into 2 equal halves. Now, if I add these two together, they'll have to equal the whole angle, which is 67. 3x and 3x, 6x. Negative 1, combine those to get negative 2. And we get 67. I'm going to add 2 to both sides. 6x equals 69. And then I'm going to divide by 6. And x equals 11.5. Angle 1 and angle 2, they're same side interior angles. I'm hoping that you remember that same side starts with an S, and so does supplementary. These two angles, angle 1 plus angle 2 has to equal 180. Supplementary, two angles add up to equal 180. Now, here, angle 1 is 4x minus 3. Angle 2, 3x plus 1. Add these together, they equal 180. 4x, 3x, 7x. Negative 3, positive 1 is negative 2, equals 180. Solving for x, I'm going to add 3 to both sides. I'm sorry, that is a 2. I'm going to add 2 to both sides. 7x equals 182. Now that I've isolated my x, I can break it down, divide by 7, and 180 divided by 7 is 26. X equals 26. 27. Find the measure of each exterior angle. I got to go back to those, there was interior angles, and then there was the sum of interior angles, and then there was exterior angles, and then there was each exterior angle. So what we're looking at here is each exterior angle. Well, if I added all the exterior angles up, I always get 360. So if I want to find each exterior angle, I'm going to have to take that and divide it by the number of sides. This is a formula that we have, and you'll have it on test day. But n is always the number of sides, dodecagon. Decagon is 10 plus 2, that's 12 sides. So we have to take 360 and divide it by 12. 360 divided by 12, 30. 30 degrees. A rhombus, A, B, C, D. I'm going to draw a picture. I'm going to just draw, it's going to kind of look like a square. It's not that big of a deal. We know a rhombus has all 4 sides that are congruent. I need to label this. I'm going to go A, B, C, and D. And And they gave me information here about AB and BC. Well, because we're talking about sides, and all four sides of a rhombus are the same, this 4x minus 2 has to equal x plus 7. I'm going to go ahead and add 2 to both sides. Then I'm going to also get this x and move it over here. I'm going to subtract an x from both sides. So now we end up with 9, and over here 4 minus 1x is 3x. I'm going to divide by 3, and x equals 3. So x is 3. You don't have to worry about these tax problems. We're not doing tax anymore. What we have here, this is your review. This is what you need to kind of look over. I hope you go back to this review off this video. Go back to YouTube on the week off. I'm sorry. Hope you go back to look at this video later, which will be Wednesday night. You're going to have a test on Thursday, and just kind of refresh your mind on some of these problems that you might be struggling with. Like I said, I'll be here on Thursday. Talk to you later.